Welcome to the Vortex Connect example walkthrough. I'm going to show you how to run the second example in this product and explain some of the mechanisms that allow an MQTT broker to send values to an open source ModBus slave simulator. This is done using MQTT and ModBus connectors included in Vortex Connect. The slave simulator I'm going to use is called ModBus PAL, the download link to which can be found in the user guide. For the purposes of this example, nearly all configuration is already completed. Follow the instructions in the user guide and you can start it straight away. The only thing that needs to be set up is an MQTT broker. For this example, I'm using a free online service from cloudmqtt.com, which has a web UI I can use to send and display messages. You can use this site as well, or any other broker, to send and display MQTT messages. This diagram illustrates the basic concepts behind Vortex Connect. Vortex Connect connectors have two categories, northbound and southbound. Northbound connectors typically interact with services or applications that allow the user to control the physical communication on the south side. However, they don't interact with this medium directly. Southbound connectors typically handle direct physical communication with, for example, sensors and actuators. The Vortex Connect model provides a standardized format for data representing the states of sensors and actuators within the model as objects that contain the latest state or associated value of a sensor. Before I begin configuring Vortex Connect, I need to identify the entities and properties that can be monitored or controlled by Vortex Connect components. These should be defined in XML and will be used by the model components of Connect to set up the required data structure for storing and communicating their values. Therefore, the XML used by the model defines the memory structure you intend to manipulate from your application. I'll talk in more detail about these later. The location of all XML files used in the Connect model is defined in the meta model XML in the example. Currently, it sources a folder containing several sample IPSO XML templates. Any of these templates can be used or modified, or you may create your own. This example uses the light control and illuminance templates. Specifically, on/off and dimmer for light control, and sensor value from luminescence. Connect components operate within an overarching container structure. The container initiates the required Connect components and calls their startup and shutdown lifecycle steps. When Connect is started, you pass the container XML as an argument. This container defines which connectors will start with the process. Each type of component to be started must have a corresponding XML schema definition file. These are located in etc, XML, XSD, and currently shows all connectors which can be enabled. Each component has a name which must have a matching XML file specifying that particular component's configuration. To start Connect, at minimum, the thread pool, scheduler, model, and meta model must be defined. For this example, we need to enable the MQTT and ModBus connectors and set their configuration appropriately. ModBus is a southbound connector because it interacts directly with sensors and actuators, whereas MQTT is a northbound connector. It interacts with the cloud service that allows users to read and control the sensors and actuators via Vortex Connect. It does not interact directly with the sensors and actuators. In the ModBus 1 XML file, the IP address is set to the loopback as the slave simulator will be local. Instance configuration defines the actuators and sensors that the ModBus connector will be reading from or writing to. Instances have unique identifiers and are associated with entity types from the meta model. You can have several instances of the same entity type within the model. The entity is the name of the IPSO object already loaded into the memory. Here we can see it in the light_control XML. All available configuration options for the ModBus connector can be found within its corresponding XSD. For the purposes of the example, on, off, and dimmer will be used. The ModBus connector here is set to write these values to the slave. The second instance is called Sensor1 and uses the Illuminance IPSO XML. It is configured to read this value from the slave. The MQTT connector requires a much simpler configuration. For this example, I'm using an external MQTT broker, cloudmqtt.com. In the XML, I specify the hostname, port, username, password, and protocol to use. The QoS here is 0, which is best effort. Client ID is the name this MQTT connector will display as. We don't need any server authentication, but this would be true for an SSL connection. Topic prefix, just to separate MQTT topics from any other that might be active, for example, DDS. And then outgoing and incoming topic names. The outgoing and ingoing here is defined from the perspective of the connector. The incoming topic name and topic prefix, then incoming topic, and at the end, the instance you are using. For the on-off dimmer values, the topic will be MQTT docs, southbound light 1. The incoming topic name is going to be used when the data is sent from the MQTT broker to Vortex Connect, and the topic will be MQTT docs, northbound light 1 or sensor 1. The outgoing topic name when sent from Vortex Connect to the MQTT broker. As for further connections, the XSD shows all available configuration options. Configuration complete, let's start the example. First, run the ModBus slave. Set the port 5020. Run and set the slave to learn. Now start Vortex Connect. Navigate to your container folder and execute the binary passing the container as an argument. In the console output, we can see the IPSO files loading. Each connector starting up, and the MQTT connector connecting and subscribing to the MQTT broker. The ModBus simulator shows an active connection, and if we click the slave editor, the holding registers and coils can be seen. Currently, as the ModBus connector is set to pull illuminance from the ModBus slave for the instance sensor 1, it has already created this holding register at address 2 with the value of 0. As this value is not changed during each pull, the ModBus connector does not update the model. If we change this value, we will see Connect update the model, and as the model instance changes, any other connectors will be notified, such as the MQTT connector. Instance updated, MQTT connector sends the information in a JSON string to the MQTT broker, which will display it in the WebSocket UI. Now let's send a string back to turn on the light and set a dimmer value. Sending the data southbound to instance light 1. The ModBus slave shows the data sent. Here, register 1 is the dimmer and coil 1 is the switch. Sending the same string multiple times will not result in the model updating, as no new information has been supplied. This concludes the example walkthrough. To evaluate or download Vortex Connect, follow the link down below. For more information, visit prismtech.com.